Can you guys hear me out there? Thank you. We want to share the desktop. Okay, sorry we're a little late today. We're just getting set up. So, let's see, where are we? Where's our mouse? Our mouse here? Our mouse is frozen. I think it's sharing the desktop, slowly but surely. There we go.
Yeah. That's been this there.
Yeah. DOS.
Have you seen Windows 8 yet?
It's a big hit. It's a big hit. What's the world come to when Samsung is more important than Microsoft? Pretty interesting. So,
because they have stolen the...
because tomorrow's announcement of their new smartphone is much more important than any new Windows release, actually. So, but that's a diversion. Let's talk about the web. So, welcome everybody. Today, I think we're slowly but surely sharing our desktop. I hope it's working for you guys out there. So today is March 13th, 2013. 3/13/13. Don't want the Ides of March. Beware. Back up your websites. Loud and clear. Great. So you can hear me. Hopefully you could see things better than I could see them here. Because I can't see anything.
Speaking of that, can you demo this?
That was that. Okay, so sorry for the late start. I don't know what's going on with the screen. So today is our last class before spring break, which is next week. So there is no class next week. Today is also our midterm. Well, actually tomorrow is. The midterm opens at midnight tonight. So in 5 hours from now. And so have a cup of coffee and black screen. Yeah, I'm getting a black screen too. Not sure what that means. Can you see me now? It's pretty cool for video conferencing. Can you see me now? Black. Yes, thanks. Okay, great. So I think we're cooking here. We might not be cooking, but at least visible. So this week is, like I said, the midterm, and I think there's not a lot of content on this week's lesson. But if you click here, it should unable to. So it should take you to the midterm exam at midnight, hopefully. If not, I'll test it. But that link ultimately should take you to the midterm. If not, I'll make sure that there's a link on our website. And that is the exercise for this week. So, where are we? Here we are this week. Try that again. There's a VR. That's me. It's my fault. I somehow, in that link, created a bad link. So that's one thing I want to talk about is you see down at the bottom of the browser screen, the browser is indicating where that link is going to lead, and I put a bad link in there, so I'll fix that. Which brings up another point, which is one of the parts of the midterm is this glossary that we created. And the glossary actually is kind of cool. It shows up, hopefully it shows up on our wiki page. So by taking the midterm, you're actually adding to the class page, right? Which is pretty cool in a way. In addition, there's another page called the glossary page. So you go to this page to choose and define your term. And that is 20% of your grade for the midterm is. And I'm giving you, no, you have to choose and define your term. So those are ones that are already done. So let me explain this. So these are the terms that are still available. The longer you wait, the fewer terms there are to choose from. So the quicker you do this, the more terms you have to choose from. Does that make sense? If you do it and you're not happy, yes. So let me explain that. If you do it, unfortunately right now on the website, when you go to the wiki, there's really no way to delete. In fact, there's not a lot of functionality to delete much of anything if you do a submission or a review or this. So I kind of moderate it in the back end, and we'll talk about where the site is going from here and how to add that. But if there is a definition here, you can add to it, right? Add or amend. So it's not add or amend, it's the same thing. And all that does is add another definition. So ultimately, if there are more than one definition, I'll either moderate them together, or it's not bad for a term to have more than one definition. You know what I mean? So I'm okay with that. One thing to remember, though, is don't enter HTML tags with the angle brackets right in the definition, because those will render as HTML, and we'll get half an A tag or something like that, which isn't good. So just put them in capital case. You know, like if you're talking about, I don't know where an HTML tag would be, video element. So to put an open angle bracket, video close bracket in there is not a good idea, because that will put a video bracket in this page. I mean a video tag in this page, or at least an opening video tag in this page, which is not something we want to do. So if you want to do that, some instructions are here. There's ways to use the HTML character code to do open angle bracket. My suggestion is just put them in capitals, and we'll all know what you're talking about. That'll make it a lot easier. Does that make sense? But right now, to take 20% of the midterm, all you have to do is go here, choose a term that you want to define, put the definition in here, and submit that. And that's all there is to it. And if you want to amend it, go to the wiki page, and you could add to that, or say, Jay, please delete what is in there, and I'm redoing it, or something like that. A few people have done that. So, and this is all available on our class page right up here, right? Like this site, bookmark. So, the wiki is here, and that will continue to be on our page, for the duration of the class. And this glossary is just a feature that will be open through the midterm, which is essentially the essay question of the midterm, right? And once that's submitted, I will grade it. The other thing that's new to the class page this week is the final project, right? So based on what we talked about last week, I put a very detailed description of what the final project should be about, how many points you get for each little thing, and all of that, right? And I put everybody's final project proposal in there so we could go through and see, we didn't get one from this person, and Carlene doesn't know. So to enter your proposal, you would do that through your profile, right? My profile, I should probably delete that. But you would just enter it here, and if you want to change your proposal, it's very easy to do. Go back here, your proposal will be in there, edit it, and resubmit it. And it should save those changes. Right? So the midterm is really three things. Take the test starting at midnight tonight. It's 25 questions. Submit a definition into the glossary. And the glossary is open to both of our classes. So there's terms in there that are applicable to HTML5 and CSS3 and things like that. You're certainly open to answer those as well. And submit your final project proposal. And if it's not complete or you don't know what you're doing, that's fine. Just submit it so we have something. So I can give you, I'm going to grade your final when you have that final, your midterm when you get that final project proposal in there. How's that? So there's no points involved, but it'd be good to get it in there. So, so the questions are 25 questions online. It's open at midnight tonight. I think it's opening through next Thursday. So, but that is, into your spring break. So, the sooner you take it, the better it is for you. The questions are pretty much 100% taken from something I've said in this class, or that was directly somewhere either on our website or less than a click away. Okay, so there shouldn't be many surprises. I mean, things I've probably said more than once since I tend to repeat myself. So, I think like I said, the best approach is, you have unlimited time. You should just take it when you have a little bit of time and have have the ability to, try things out. Because it's typically, it might be a question, how does a Boolean work? And you could look that up, or you just could build a very simple PHP page and try some of these questions out. So, it's a good idea to at least have your web browser and be able to look things up, but there's no reason why you can't even try some of the questions and find out what works, right? So, one question is like, what does PHP stand for? Does anyone know that? Anyone know that? I don't know. PHP. What does PHP stand for? So I've been teaching this course like I said, this is I think my 4th time. I don't even know. Hypertext preprocessor.
It's PHP hypertext preprocessor.
PHP hypertext pre.
There's a name for that kind of work, right?
Yeah.
Yes.
It's an overused acronym or something. So
no, I mean, GNU does the same thing. The first word of GNU is, the definition for GNU is GNU. Yeah. And then whatever.
PHP hypertext. This confuses many people because the first word, it's a recursive acronym.
That's it.
A recursive acronym. So does anyone know what recursion means? Recursion is an important term. We could look it up. I should have put it.
I know what a recursive function does. It calls itself.
Recursion is a Wikipedia definition. So we'll give a chance of somebody at home to raise their hand. A function that calls itself. Steve, that's very good. Paul was on that track as well. So it's recursion in programming is typically implemented as a function that calls itself. It's a block of code that's aware of itself and can embed itself in a way, or nest itself in a way. Of course, there has to be bounds around that, or you get an infinite loop, right? If you have recursion without some bounds around it, so there has to be some kind of breaking point at some point. At a more general level, I don't see what is the process of repeating items in a self-similar way. So another definition of recursion is the ability to take one thing and put it in as a component of another. And we spoke about this for more than half the class last week. We talked about the concept of master detail or hierarchies, and that really is the same concept as recursion, right? A hierarchy is one way of a model of seeing recursion. One order with many order items, right? So an order item, what it is needs to be defined once, but there can be a series of them, right? And they're contained, the operative thing for recursion is they're kind of contained within one, within one another. One piece is a component of another piece. In programming, we do that all the time. And once you do that, you have the ability to iterate through things that look the same, like an order item, or a track that's part of an album, or whatever, right? So recursion is a very important concept in programming. It is the definition of kind of PHP somewhere in there. Where is that? A recursive title is an example. So it refers to itself. PHP, the name, has PHP as itself. That's what they mean by recursion. So I read this interesting article, which has nothing really directly to do with programming, which is about the theories of this guy named Noam Chomsky. Does anyone know who Noam Chomsky is? He's a linguist at MIT. And it's his theory that what makes humans human is that they understand the concept of recursion. And that enables them to have language. Because language in humans is based on being able to embed one idea into another. A couple of phrases can make a sentence. And a sentence can make a paragraph. And in a very simplified language, kind of like what dolphins could do, or whales, or other species, they could communicate, but they can't embed one idea in another. They can't say, that green dolphin is, doing something there. They have to speak in very discrete, they can't put two phrases together. So when we do computer programming, we're really exercising what we learn inherently as kids, how to put language together. And it's important when as you do this type of stuff, especially in what we're doing, is to find the patterns. Because, I could go through this class and give you the step-by-step. Put this code here. This is going to be a for loop here. But when you leave this class, that's not going to be very helpful. What's going to be helpful is if you can take a step back from looking at a situation and say, here's how I would go about putting together a solution or some way of automating that situation. And being able to understand that situation sort of conceptually is a very important concept, right? Even if it's something very discrete, like tracks are part of albums are released by artists, are kind of part of a genre. If you're going to build a website, which we'll do in the next week or so, that enables somebody or something to manage that information, you kind of have to think conceptually about how to use that and how you want to put the whole thing together. Because it's very easy to put something together and then it doesn't do what you want it to do, right? You can kind of see that. It'd be very easy, to build a form that does something that doesn't really do anything, right? Now, a simple form is very easy. We did that earlier in this class. A one-entity form, a contact form. What's my name? What's my number? Call me. There's not a lot of information in there. In fact, there's no recursion really, if you think about it. But even just something as simple as tracking your CDs or your record collection or your whatever, MP3s, you get into this concept of recursion. How do I want to track them? By album or by track or by artist? And how do I want to organize it? What's important to me? Is it genre? Some people don't care about that, So we built a very simple database that, like I said, we had to make decisions about last week. An artist belongs to a genre. But there are exceptions, and that might break down the road. You have crossover artists, right? You have Tony Bennett, who, is kind of easy listening that went into whatever, pop or whatever. So data models can change, and it's important that we model them importantly, and that's where this recursion thing comes in. So at the end of all that, I will say something. What PHP means is not going to be a question on the test. I just thought I'd look it up. I didn't know what it was. All right. I'd heard once, but I didn't remember.
So what's going to be on the test?
What's going to be on the test? There's going to be questions about PHP, about MySQL, probably about 10 questions on PHP, probably about 7 or 8 on MySQL, probably a couple of general ones, and some on JavaScript. The JavaScript ones won't be very detailed, like at the statement level, because I don't think we really dove in at the statement level yet. More like, how do you work with JavaScript? In fact, most of the questions will be more, how does all this stuff come together? There might be some very specific syntax, but not a lot. Let me put it this way: if the glossary terms seem pretty straightforward to you, you should have no problem on the test at all. It's not going to be a hard test.
Are we going to be able to print this test out?
Yeah, so you could print it out, but there's no limit to the number of attempts or times. So if you want to save paper, you don't need to print it out. Okay. Yeah, but you can do that. Any other questions about logistical stuff? Midterms, final projects. So a couple of things. Like I said, I haven't done this yet, but I've started to put together that newsletter subscription system, and I will open source that so that you can fork that and use that as a starting point for your project. if that's something that would give you inspiration or is of interest to you. Take me a little while to do, but I think it's a good starting point for those of you that want to do that. The other thing is, I would even be interested in having you fork the code that's behind our class website, because you know it's just a PHP JavaScript application, MySQL application, and you know there's many features that I'd love to add. If anybody wants to talk about that, I'd be glad to see some. Like one question is, that I get all the time, how come I submit something, I can't delete it? That's frustrating. But hey, you know, I just haven't had time to add a delete feature in that works at the right level to make sure it has integrity and doesn't delete things that shouldn't be deleted. So if somebody wants to take that on as a project, that'd be an interesting thing to talk about. And there's plenty of features in here that we could do. And we already have a student in one of the classes that is helping out on this site for a project. So that's something to think about. But like I said, this is nothing more, our class site is nothing more than what you're learning in class. It's a little bit over, it's more than I would expect you to bite off as a project. Does that make sense? It's bigger than I expect. So, but taking a piece of it and saying, I want to build a messaging system so students can talk to one another, something like that. You know, coming up with a proposal like that would be an interesting project. Okay, let's see if there's any questions from the peanut gallery. It was very tedious. It was very tedious entering the data using Workbench. So, what data did you have to enter in the Workbench? I'm not sure. And yes, it is tedious entering data in the Workbench. I mean, it is possible to do that, but that's why we're learning what we're learning. If it was easy to enter things in Workbench, we wouldn't need web apps to manage our data, right? So yeah, if you add them to the Workbench, yeah, it's going to be not a very clean interface. So, where are we? We ready to move on? Any questions? Anybody ready to like do more coding right now? Yes.
So what would you say is stronger with more functionality, PHP, MyAdmin, or MySQL Workbench?
So the question was about another tool called PHP MyAdmin, which is an alternative to MySQL Workbench. Both of them are database administration tools, but they're very different. MySQL Workbench, which we've been using in this class, is a remote database management tool. So when you launch it, the first thing you do is you create a connection to a database. Because MySQL Workbench is running on this computer, but the database is running on another computer, just like a web server connection. It runs over a network. PHP MyAdmin is an administrative tool for the database that's implemented in PHP, but it runs on the same server. So you sort of launch it, and it's closer to the database, and that's one difference. Another difference is it's a web app. You know, it's purely in a browser. Everything is in a browser. I cannot show it to you, unfortunately, because we don't use it at the JC. The JC IT staff say it's a security risk, which I don't understand. I would think a networked one like we're using would be a bigger security risk. I don't understand it, but they thought it was a security risk, so they didn't want us to use PHP admin, even though we used it in earlier teachings of this class. So we're forced to use MySQL Workbench. PHP admin, you know, they're both do about the same. They just look a little different. PHP admin looks like a web application. It doesn't use a lot of Ajax, you know, so you go from screen to screen a lot. There's a lot of drop downs. MySQL Workbench is a little cleaner because it runs on a desktop. You could cut and paste things a little bit easier and things like that. it's a little flaky for a couple of reasons. One, it's written in Java. So Java, unlike a native application, like Flash, there's an interpreter between the real world and the program comes with its own interpreter, and usually that's not as robust as an operating system, number one. Number two, it's a little flaky because it's free software. So there's not a lot of support for it from Oracle. In fact, the community that relies on it a lot is always worried that Oracle's going to stop supporting it. They're actually worried they'll stop supporting MySQL Workbench. I mean, MySQL as a whole, but I don't think they could do that. I think the government wouldn't allow that. There's another tool that, if you talk to the people at Oracle, I used to work at Oracle, and all the people at Oracle love this tool called Toad. And I don't know if there's a free version of it, but it's from a company called Quest. And this is supposed to be like the state-of-the-art tool for database management, SQL database management. But I just don't think it's free. And now it's owned by Dell. I don't know. You'd have to look at their. I just came to this. So there's freeware, Discovery Wizard, Spotlight. So there might be some versions. So for MySQL, there is a free version. So you might want to download that and take a look at it. I think I'm going to do that. I'm not going to do that right now, but when I get some time, I'm going to take a look at Toad, and I'll report back as well. And if you want to take a look at that as well. But I'll tell you, when I worked at Oracle, the developers all used Toad. They didn't use MySQL Workbench or PHP and MySQL. So, and that was a while ago. That was before Dell bought Quest. But and Quest was a company that was started by an ex-Oracle guy. So does that answer your question?
Yes.
Good. So Vinny owes me a sale there. I just turned you guys on. Okay. Let's see. Any questions about what we talked about last week? Let's see what we did last week. We created a database. We didn't really create a database. I created a database, and we implemented it. Right? Do you remember that? We created the tables. We ran the script. Right? So where is that script? The script is right here. And this is a script that was created by MySQL Workbench. And what it does, we went through this last week, it creates the tables that comprise our database, and then inserts the rows, the data rows, into the tables. And I made up, well, I didn't make up the data. The data is real, but I just arbitrarily took 4 or 5 different albums of music and put that information in there. So there's a track table, there's an album table, there's an artist table, and there's a genre table, and they are a master detail of each other. Right? We talked a lot about what that and what that means, and what that pattern brings us by using it, and that it doesn't have to be that way, that some data designer decided that that's the way our database will look. Let's see the question. How do you get a printout from 2 things, e.g. album and year? So I had a trash on it. So how do you get a printout? So good question. So let's log into MySQL Workbench, and you could do this, follow along, or I'm just going to log into my own account, and I lost the connections from last week, so I'm just going to put student.santarosa.edu. Okay, I'll be right there. There he just finished typing. Okay, so let me just click on that, and then let me get the door here. How do you get a printout? So, Let's see, any questions? You can use them. Thanks, Sergio, but I got my own this week. And thank you for letting me use yours last week. And Tony, thank you for the week before. Hopefully you haven't gotten hacked. So, okay, so here's I just connected to my database, and we'll spend a little bit of time now talking about the language of SQL. We started talking a little bit about it last week. We looked at some insert statements, right? So if we go back here, drop table if exists tracks. That is a SQL statement. That's an example of, remember I said in general there are two distinct types of SQL statements. And then within one of those there's four types of that. So the main two types are, does anyone remember? There's, at a high level, there's two types of SQL statements. And data manipulation, or those are big words, statements that create tables and statements that put data into tables or take data out of tables, right? So SQL, the language, does both. You start out with nothing. You start out, a database is a tabula rasa, there's nothing in it. And then with SQL, the language, you actually create the structures. What we're doing here is deleting any structures before we create them. Kind of like SimCity, blow the building away and recreate it, right? So drop a table if it exists. This would be dangerous. You don't want to do this, right? Does that make sense? A database administrator would only do this in certain circumstances. The reason this is here is because it was generated from the export from MySQL Workbench. So what it's designed to do is recreate the database if you need to re-import it, like a backup and a recovery. So we would drop the table and recreate it. But the point is, this is what's called data definition language in SQL. It creates tables and structure. And then this is another data. Now, Carlene got the answer, but she's taking the SQL class. So, but anyway, that was good. So this is another example of DDL, data definition language. It's not putting data into a table. It's literally creating the table. And a table is nothing more than what? The sum of its columns. And some other things like foreign key restraints and things like that. But essentially, the core of it is the sum of its columns. So a table is defined by its columns, which are in parentheses following the table name. Create table, the name is tracks, and in parentheses we put the columns and their data types. And then we put information about the keys. What is the primary key? And does this table have any foreign key relationships to other tables? Right? We also tell it what storage engine to use. So for the purposes of this class, we always use InnoDB. MySQL has different storage engines, different underlying technologies in which the data can be stored in those tables. InnoDB is the one that allows us to have foreign key and primary key relationships. So for the techniques that I'm teaching you, you have to use the InnoDB storage model. There are other storage models. In fact, the default used to be another one. And you used to have to change it to InnoDB, but now I think it's the default. So you don't need to remember that. It's not going to be on a test or anything. It's, you know, well, you do, Carly. But if you know, it's really more for the SQL class. But I'm just giving you a heads up. If you have trouble creating a table that takes a primary key, make sure that InnoDB, this word right here, is your storage engine. And here, I could tell you what the other ones are. Let's edit the. Yeah, MyISAM is one. So let's alter this table, and we could change. So there's a lot of different storage engines. InnoDB, I don't know. I don't know if that's what. But I think it is now the default, and it's the what these storage engines mean is. A table is not something that's stored on disk. It's a virtual thing. And there are, what these are is the actual mechanism to store the information on disks. What kind of file are we storing it in? And InnoDB is the only one smart enough, at least as far as I know, to do the things we're doing with relationships between tables. Okay, so I'm not going to get much deeper in that. I don't even know what these things are. Mr. G, my iPad. I don't know if you want to use that one. So let's see. So SQL. So if we go back to our script, we have some DDL, and then this is our first real SQL statement. Our first, well, that's not it. Our first DML, data manipulation language. Well, the first, and remember, when you're writing your application, you're going to spend some time designing how your tables look and how they fit together. You're going to spend a little time implementing those using this data definition language like drop table, create table. But when you're writing your application, 95% of it is really the data manipulation part of SQL. And that could be divided into 4 different statements that correspond to CRUD. Right? Remember we talked about CRUD. Create, read, update, and delete. So insert corresponds to create. You're creating a new record. Even though the create table SQL statement starts with create and it looks like it relates to create, this is really where you're creating data. Right? This is where we're entering tracks into the database. So so there are 4 statements that correspond to CRUD. Insert is the C, create, right? Update, the U is in SQL update, right? So those correspond directly. Delete is delete in SQL. Delete from tracks where artist is equal to Lady Gaga. She's like so last year. So to delete things, it's delete and update. They correspond. The verbs in SQL correspond to the CRUD. Create is insert. Read is the select statement. Select. And that, we're going to dive a little bit into the select statement. And we're going to do so based on Anna's question. How do I get, she used the word print, but how do I get, it's cool that I put this data in, how do I get it out? Right? How do I make sense of this data? Right? How do I show the data in some kind of context? Especially since it's all in tables that are distinct. The albums are in one table and the tracks are in another and the artists are in another. Right? So that's what we're going to go through next. Lisa.
Update and inputting or taking out is the same. When you're updating, you can either be putting in or taking out, and then you're moving is the final.
Yeah, so when you're updating, so that's a good question. Maybe I should explain that. So CRUD, if you think about it, the discrete thing that we have to deal with in an SQL database is a row. Right? There's a row, one or more rows of data. And everything that we're storing sits into some kind of row. Right? In fact, even more specifically, into a column within a row. Right? So when I say CRUD, what I'm saying is it's a model. It's a simple way for programmers to say there's only 4 events we can do with a row. We can create a new one. We could delete one. We could read one or more rows. Or we could update it. What I mean by update is not create or delete. It's select that row, change it, and reinsert it back into the database. Change it in place. So you're right. Insert and delete are also updates, but they're not. When we say update, we're talking about a row or a set of rows. So if we wanted, if the Beatles broke up, well, that's not a good example. If George Harrison changed his name to Swami something, right? We could update all those records. We could go in and say, update artist, set name equal to this, and it wouldn't add a new record. It wouldn't delete his previous record. It would change the information in that record. But that point is very important. All of these CRUD statements and everything we do in SQL, when it comes to data manipulation language, deals with rows within tables. So that's something, you know, I hadn't thought of sort of using as a way of illustrating. When you're doing the definition of your database, you're dealing usually with tables. You're defining the columns within tables, but you're really creating a table all at once. You know? But when you're working with the data, you're doing it typically at the row level. It doesn't mean that one statement is only affecting one row, but those statements pertain to the information which is in rows. So every operation will be row specific. So for example, and we've seen this already. Every time you do something in SQL, what's the first thing that SQL Workbench does? It says how many rows were affected, right? Which is a good example. So let's play around with SQL and we'll look around. So the first thing you have to do, it's a little bit frustrating, especially at the JC where we only have one schema, is to tell it what schema you want to use, and that's just a quirk. So the use statement allows you to do that, and if I don't execute this, it won't know what schema, even though I only have one schema, it won't know to use that. As an alternative, I could put the schema in the select statement, and I'll show you that in a second. So at a very high level, I could do select all from genres. And I think that will give me a listing row by row, and you can see 4 rows were returned, right? So this is the CRUD, this is the C, this is the R, the read, the select statement. This is the universal. Give me all the columns. I did that because I didn't remember what the columns were, right? So now I could go, give me the genre from genres. And it'll just give me the 4 rows that have, and the information for their genre, right? If I go back and look at all the columns, this is a primary key, as you remember, that we created using an auto increment, right? So it's essentially a serial number. In fact, Oracle calls these serial numbers. MySQL calls them auto increments, but I think Oracle, it's called a serial primary key or something like that. So, but this is, the important part here is parsing out what this is doing. Select, this is the columns from and what table, right? So, and another thing is I could qualify the table with my schema ID, right? So this statement is synonymous to use JPERETZ and then select from genres, right? But this allows you to go across different schemas to select. At the JC, we only have one schema, so not a big deal, right? But just so you know. Okay. Here, we could do this. We could do select genre from genres, and then there's one more clause we can add to the select statement. Order by genre. And then, as you can see, we have jazz, rock, classical, world. When I run this, it's in alphabetical order. Right? So SQL select statements have, they always have the word, they always start with the word select, right? And then they have the columns that you want to display, and then they have the table, and then you can have an order by clause. Right? Now, an order by clause can be either ascending as it is by default, or it could be descending, and then world, it's now reverse alphabet. Right? So, does any of this make sense? Right? Very, very simple SQL. Right? So, this is great, but genre really doesn't help me. If you think about it, how do I tie this together? What what artists belong to what genre is really meaningful information. The list of genres is not very useful, if you think about it, right? So to get information, well, first of all, if you remember, we specifically decided to keep genres and artists in different tables because one genre could have thousands of artists, and why write the same genre each time? You know, like rock and roll, and if that changes or gets misspelled, your database is all corrupted. So we decided to do that, but now, at the point where we're trying to make some sense out of this data, it's an impediment. We have the data in two tables, and we have to somehow figure out a way to get the data together again in some meaningful way so that we know what artists belong to what genre, right? So let me just get the door, and then we'll see. I added year per album, and wanted to list albums by artist by year. Okay, so that's good. So if that's what you want to do, let's do that. So you get the concept of a single table select. Let's do what Anna wants. Let's alter the album table, and let's add a, boy, this interface really. How are you supposed to do it? How am I supposed to get in there and edit it? Any ideas? Come on. There we go. Okay. So release year. And let's just make that an int, right? And apply that. Okay, so now I have a place to put a year for each album. Now let's edit our albums table. And let's see how good you guys are here. Kind of blue, 56. Miles Davis, you don't know? Giant Steps, I'd say probably, let's say 1958. I don't know how close. Somebody could get on Amazon and look this up. 1967, I could tell you where I was when Magical Mystery Tour was released. Sgt. Pepper, 68. Abbey Road, 1969. I don't even know what this is. I just got it off Amazon. Let's say 2007. Bob Marley, it's got to be mid-80s, right? 1982. Says the Rasta guy here. And this was a later album. 1985, let's say. Right? Anna probably knows these better than we do. Okay, so now we have dates. Right? Now we could do some querying, right? We could get rid of this. We could get rid of this, and we could say select all from album order by release year. And albums, thank you. So I put release year. Which probably isn't a great way of modeling it, but obviously this is, if you're tracking this information, you'd probably put a real date in here. You know what I mean? Because people might be interested in that. But for us, we're going for simplicity purposes. And as you can see, we could go ascending or descending. And if we go descending, you get the highest first. So, so this is cool, but we have no idea who made these albums. Right? The artists. We could go select everything from albums, and we have an artist ID. And then we could do select everything from artists, and we got an artist name and an artist ID and a genre ID, but we don't know what albums, this says anything about an artist except the albums he released. Right? So how do you think we could put this together? Yeah, we have to do something called a table join. We have to, using SQL, we have to tell the database that these things are related together in some meaningful way. Okay? SQL, we put the foreign key references in when we define the tables, but that doesn't drive the select statements. The select statements are not aware of the foreign key relationships. Does everyone know what I mean by a foreign key relationship? The ID for artists, so the Beatles are number 3, and then if I go back to albums, you guys are too young to know this, but any of these albums with an artist ID of 3 is released by the Beatles. So that's how these foreign key relationships work, right? So it's going to be very simple to implement it. What we're going to do is select everything from albums. Well, let's do this. Select album from albums where, so this is a new clause, right? A new clause. We have the select clause, we have the from, all of these are keywords. You don't have your choice. You have to write select. That's SQL. Then you can put your tables in. That is your choice. You can name your tables whatever you want. Then you say your columns. Then you have your from clause. Again, that's a SQL word. You have to use the word from. And then you have your table names. And then we've learned another clause before, order by. Again, you can't make that up. The order by has to be written out. So that it's a SQL command. A fourth clause in the SQL select statement is where. So we could say select album from albums where the artists underscore ID artists, it's a crazy name for a foreign key, but that's the way they do it, is equal to 3. And then because I just looked at the artist table, I know that's the Beatles, right? So if I run this, I get all the Beatles albums. And I could still have my where statement. I could say, my order statement, order by release year. And they just happen to be in that order because I copied them from Amazon or whatever. But I could do, descending, and they should reverse, right? So but that isn't very. That's useful, but not very useful. We didn't really join the tables. We just we knew what the foreign key related to. Does that make sense? The better way of doing it is like this. To change your where clause to say where, watch this. I could, in my from clause, I could add a second table. Select the album name from both the albums table and the artists table. Now there is no album name in the artist table, but SQL doesn't know that. It's just going to try to figure out rows from this. The way we get these rows to correlate is in the where statement. Here we're going to say, instead of where artist equal to artist ID, let's just say where the artist underscore artist ID is equal to ID artists. This column is in the artist table. This column is in the albums table. And whenever they are equal to each other, what are we going to get? We're going to get a join. So we're no longer going to get just the Beatles albums. We're going to get all the albums. But we could also get the artist's name, right? And the way to do that is pretty simple. We just put that column name in here. And then when we execute this, and then let's get release date. Release, thank you. And run that. And now we have in descending order because we left our, oh no, we took that out. I thought we left it in. Let's do this. Yeah, so we left it in there. Order by release date descending. So if we do this, we should see that reverse. So now we have what Anna was asking for, right? a list of all the albums with their corresponding artists in the order of their release date. Right? And it was pretty simple to step through the process of figuring out how to join the tables together so they made a logical row. How many rows are there? How many of these rows came from the artist table? Yeah, so there's 1, 2, 3, 4, there's 8 rows total, but there's only 5 different artists. But some of them are repeated because they belong to those albums. So what SQL does with a join is try to create, what a select statement does, is create temporary rows based on what you've selected out of rows from the tables that you selected from. And when you do a join, it'll create virtual rows. It'll find the matches and create a row where they join together to give you the behavior like this, which is what you want to see. This, this is correct. This is what you want to see in something like, an iTunes library. A row for each entity, the album entity in this case. Does that make sense? Let's see the question for a moment. Jay, can you write your statements on multiple lines? Very good, very good. Yep, that's my problem. I can't even see it. So I'm going to write them clause by clause, and that's a good point. A lot easier to see. Does everyone? So now it's a little bit more visible, and you can see that the keywords are in green. Those are the, I think you can see the green at the end. Those are the SQL words. That's SQL syntax. Select, from, where, order by, ascending. Those are SQL words. Now there are different ways to do joins, and different databases have slightly different syntaxes. So there are a few people in this class that are taking the SQL class, and you might learn different ways of doing inner joins and outer joins. For the purpose of SQL is a class you could take, it's probably even in one semester is probably not enough, So, we could go really deep into SQL. For the purposes of this class, I think this is probably about as complex a SQL statement as we'll use. And I'm using a simple way of doing a join, a way where you can actually see how it works, where the keys are being equated to each other in the where statement to filter the results in a way where you get a logical view of the data, right? Like I said, there are other ways of expressing it in SQL, but it might not be as intuitive. And part of my approach to teaching is I try to teach how to do things as professional industrial strength as possible until the code gets so complex that you really can't get the concept. So in this case, there are better ways. There are SQL people that say there are better ways of writing a statement, but it would be too complex for you to understand. So anyway, I thought I'd throw that in. Lisa.
Is this all combining what you would consider a query statement?
This is a query statement. Yeah. So structured query, SQL stands for SQL, otherwise known as SQL, stands for Structured Query Language. And this is a perfect example of a two-table inner join query, right? Which is a very, very common technique, right? You can have a three-table inner join query if you want tracks or genres in this report, or a four-way if we want both, because those tables relate in a master detail. Question, would you please parse each line? I will parse each line. So I think I've done that, but let's do it again. So select is the verb. And if you notice, all SQL statements start with a verb, and that's a good computer language. This computer languages are supposed to give commands, right? So select, we're telling it to do something, and we have to tell it some coordinates. Select from where, right? So you can only select columns from tables. That's not true. You could mess around with the columns. in some SQL dialects. You could say select year and concatenate AD on it and put that on the report, right? So you can mess around with columns, but in essence, in the select statement, you're really selecting columns of some variant of them, and you're doing it from tables, right? And then where? You know, obviously, that's a conditional. Does that make sense? Where this condition is met. If we take this out, we're going to get what's called an outer join. If we don't join those tables together, we're going to get what's called chaos. Every album will be joined to every artist, because the SQL select statement doesn't know that artists released albums. It just knows that you asked me for information from 2 tables. So I'm going to go through and give you every permutation possible to join those 2 tables, because you didn't tell me how to join them. So this is like a cardinal rule number 1 in SQL select statements. Whenever you're joining 2 tables, know what you're doing. Try, you know, this statement doesn't make sense unless there's an inner join there. But that's just this statement. There's some statements where you want an outer join. You know, I can't think of an example right now in our database, because we have a really well-designed database, a series of 3 cascading master detail relationships. And inner joins are perfectly related to take care of that, as I just showed you. But outer joins sometimes are necessary. Carlene, could you think of one? Yeah. Yeah. You could do that at the table level, but the important point here is, well, a couple. First of all, that where is a conditional. It's a filter. We don't want all the rows. We want only the rows where this condition is met. Right? So we could do this. We could do where the artist's ID is equal to the artist's ID. So that's our relationship again. That's our inner join. And artist is equal to Bob Marley, right? And then and artist. Here, let's put this on the next line so it makes sense. So now we should get, what should we get? We got an error. Well, we have an error. But we didn't get any data. Where artist where artists, I think it's this, right? Nope. People at home always get it. Where artists, thank you, Speedy. Collaborative process here. All right, so we still get 0 rows, I think. Boy, this interface is really awful. Select where artist, I think it's artist ID. Yeah. So we get both Marley albums. All right, so we have a double conditional statement, right? One of the conditions is used for the inner join to say, I only want you to return rows where they match, where the artist in one table matches the artist in the other table. So that kind of creates the real world. Without that, we've got chaos, like you saw before. And once we have that inner join creating the world as it should be, then we can add additional conditional statements to it, where our artist equal this. So we could say where release date we would use year, of course, is greater than 2000, or let's do less than. And we're going to get everything but that overture, theoretically, right? Right? Because we expressed year as an integer. So that should give us, you know, or we could say where artist is like. And you could use a universal. The, let's say, or let's do mile, and then a percent, which is the string universal in SQL. And we close up that string, and then we'll get all the albums that were released for an artist that's name starts with M-I-L-E, right, or whatever, right? So it's a different expression. What is this? This is an operator. It's not the equality operator, it's the like operator, which is, you know, a simplified string search replacement thing. And so the key point is the syntax, and knowing what the syntax is. The other thing we could do is, so let's do this. Let's go into the tracks, and let's select all from tracks. It would not, well, it wouldn't catch any, it's a good way to catch spelling errors, yeah. So if you know somebody's name is Mile, or you're not sure what it is, then yeah. That's sort of auto, that's type forward and type ahead. Yeah, that's not what this is. This is just a universal to say, and you can put it anywhere. You can put it at the front end. You could say %, S, and then it'll give everybody whose name ends in an S. So it's just a universal, one or more characters. That could be anything.
So the percent sign is one or more characters?
The percent sign is one or more characters. Yeah. And there's tons of SQL documentation out there. Like I said, SQL is at least a full semester class, so we can't go through it all. But what I want to show you here is, what do I want to show you next? Let's see. Let's do this. So, what happens, so we looked at selects, right? Let's say we want to insert data into the database. So, we need some data to insert, right? So let's go find some data. Let's go to Amazon, look up, what am I doing? Amazon, go over here, go to music, let's say, and type in Kind of Blue. And so here's this album. And, oops. And we've got all these songs in here. There might be, a lot of times there's like additional, like the re-release with new recordings. Let's see if I could find that. Yeah, they add all of these tracks. So this is probably taking longer than I wanted. Let's do this. Here's one. So they're going to create a new track for our Kind of Blue album, right? So let's see what we need to do that. Oops, wrong that. So select all from tracks. Here's our track. Do we need to add a new album? We already have the album, right? So we need to know what the album ID is, probably, right? And we can see that right here because we know that this is the album Kind of Blue because we know that that's it. So what we would do at a very simple level is this. Insert into tracks, and then we put the column names that we're inserting data. So we're going to give it the albums _ ID albums data. That's one column we're going to give it value for. And the other is going to be the name of the track. So those are the columns that we're inserting. And then we would put, sorry, I'm going to create a new line here so it's easy to read. Insert these values. So values is an SQL keyword. These values, the data that you want to insert. These are the column names. So this is going into album 1, so we would just give it a 1, the integer 1 there. So it ties back to kind of blue, right? That should make sense. We're creating a foreign key relationship here. And then we just give it the name. So we would go, you know, and I could just paste it from when I click, if I don't want a leading space there. Pasting things like from copying from Amazon is always a very dangerous thing to do because there could be a bunch of style and span tags in there. And you know, but I don't think that'll get into MySQL Workbench, so I think it'll be all right. And then I would close this parenthesis, right? I think by being in double quotes, these parentheses hopefully are safe. The alternative take parentheses, we'll find out. And what else do we need? Do we need an order by clause? Do we care what order? Is there any order when you insert things? It doesn't really matter. Where? Insert statements never have a where clause because it's a very simple thing. You're inserting data. So we would literally just put the semicolon there and run that. And we didn't get anything returned, but if I need insert integer, 1 row affected. So I think it took. Let's do this. Albums ID is equal to 1. Album. So it's, what is it? ID albums. Man, I always override that when I do it because they give you really bad names. So now I have all the tracks for this album, and I've got the new track in there. And so it's in the right spot because I gave it the foreign key. It looks like all the other tracks. I didn't need to add the serial number. SQL, because I defined that as an auto increment, and if I look at if I alter the information from my albums table, and if it gave me the chance to look at those columns, you could see that ID albums is auto increment, AI, which means I never have to give it a value. It'll create that value when it's inserted, and that value will be a serial number. So I know, what do I know? I know who the first person that did a definition on the website is, and I know who the last person who did a definition on the website is. I'll have a serial number for each of you. So, you know, whether Paul and Tony were fighting over a term earlier today, I know who got, well, I don't know who started first, but I know who submitted first. So that's the way serial numbers work, right? They're just arbitrary. They're not arbitrary. They're serial, but they're a very good tool because you don't have to worry about it. They create a primary key for you, and it's guaranteed to be unique, right? Is it always going to be in order? It might not, because we might be able to do something like this. Delete. Do we delete columns? Is it possible to delete columns? No, you can update a table and set a column to null, but the delete statement never deals with columns, so you don't need, it goes right to from. Delete, in fact, it doesn't even have a from. Delete tracks. I think it's actually delete table tracks. No, it's delete from, I'm sorry. Delete from tracks, and then does it need a where clause? I hit my insert key. Where's my, how do I get out of insert? Okay.
On the keyboard.
Where on the keyboard? Nope. All right. Delete from tracks. Somebody has to help me find the cursor. Found it. I get the points. All right. Delete from albums. Can we do, or from, let's not do that. Let's do from tracks. You think you can do this without a where clause? Do you want to do it without a where clause? Probably never, right? I think in most cases, if you go like that, it'll give you an error. Let's see. Yeah, delete from tracks. You are using safe update mode.
And that's your primary key.
Well, because it would blow away your entire table. And in most cases, you don't want to do that. So if you go into the preferences for MySQL Workbench, there's something probably here called safe mode. And if you turn that off, it'll let you do that. You probably don't ever want to do a delete without a where clause, because why? You can just drop the table. You know, now if you drop the table, you lose your definition of the table. You lose your columns and all of that, and everything that's related to it. Yeah. So but you would typically, as you can see, SQL Workbench doesn't want to allow you to do that because it's a dangerous proposition. But if you put a where clause, if you get where track is like, and let's get rid of that last one, right? So let's go percent. I think it's like edit preferences, but this is in Windows, edit preferences. So what are we going to do here? We're going to delete all tracks that have an opening parentheses in their title. And that should just be the alternative track, maybe. We don't know. Let's see what happens. So it doesn't even want you to do that. Delete from tracks where it doesn't even like the like. So I think you have to do something like where track. What is it? Track ID track is equal to, what was it? 37, I think. 31. You have an error in your sequence. Delete from tracks where ID tracks is equal to. I still have an error. You're an error. So, one row affected. Right? So I don't know if I can leave the right track, but there was a track 31 in there. So if I do select I get all of my tracks again. And if I go to the bottom, because it's going to be listed, yeah, so it was 31 probably. Right? So we learned select, we learned delete, we learned insert. Update is pretty much the same. If we want to change, let's see, let's update tracks. Let's do this. Update albums. Set artists, ID artists equal to 2 where album is like Sergeant Pepper. So what we're doing here, what are we doing here? We're going to update the, here, let's spread this out a little bit so we can see it. Update the album table, set the artist's foreign key, right? This is a foreign key column, which points to the artist that released that album. I don't know who released this album or even what albums these are, but I'm saying assign them to somebody else if they're not assigned to 2. So now, what this will do is mean that John Coltrane will have released Sgt. Pepper, theoretically, right? So let's see if that'll work. You could. You are using safe modes. So it even prevented me from doing that. So if I do where album is equal to, and I give it, you know, like the name maybe, like Magical Mystery Tour. Let's see if it'll take this. Yeah, it won't let me do it. I can only delete or update from the primary key when I'm in safe mode. If I turn safe mode off, requires a reconnection. So we'd have to unconnect and reconnect to do that. So let's do that. Let's get out of there. Let's copy this for a minute. Let's get out of this connection. Let's reconnect. Hey, still there. Pretty cool. And now if I run this, it allowed me to change that row because I'm no longer in safe mode. So now if I go back to my original select statement, select album, artists, from albums, artists, where albums dot. So I could qualify a column by putting a dot and its table before it. Right? Does that make sense? Why would I want to do that? Some columns are more than one. Some tables have columns with the same name. Right? A column you can have 2 columns with the same name in the same table, but you can have them in different tables. So you could qualify it by giving it a dot. Albums dot, what is it? Albums underscore ID albums. No, this is going to be artists. Or else it won't join it. I think it'll join it either way. Okay, so what are we doing? We want albums for each artist. So we want to join on the artist key. So this is wrong. Because this is a simpler way for me to do it. I don't know. As I said, I'm trying to. There are better syntax to do the joins, but I learned this way at Oracle, and I think it's more visually easier to understand. Don't tell the Dom that. So this should be artists dot ID artists is equal to albums dot artists dot underscore ID artists. So this will give me theoretically all albums with their artists. And somehow, through some crazy historical thing that we just entered, Magical Mystery Tour was released by John Coltrane. Because he's artist number 2, and I just updated that data, and that changed the whole history of music, in a way, you know. But it shows you how relational databases work, right? It uses the concept of pointers. Foreign keys are nothing but pointers. It says 02, but that represents John Coltrane, you know. So, and there could be a whole bunch of tables hanging off of that might represent, you know. So anyway, this is quite a bit of SQL, you know. In fact, this is pretty much the whole SQL language. As I said, it's divided into data definition language, which you use when you build your database, and then data manipulation language, select, update, insert, and delete, which you use in your application. Because what is an application? What is a database application? It's a whole bunch. You know, what is our class web page? You know, it's a whole bunch of. It's nothing if we're not logged in. Security is too high on this thing. So, what is it? Oh, that's probably why it made me relog in. it is nothing more than a bunch of SQL statements. Everything on this website, when you go to, let's say, our this page right here, this is a select statement, right? Somewhere in the database I wrote all this up. What is this? This list of terms. It's coming from a select statement, right? I didn't enter those terms in HTML in a select option. Does that make sense? So do you want to see how that works? Do you want to see the code behind it? It's pretty straightforward. So what we could do, the easiest way to do it, almost ready for a break, is to, man, you are good. That's good. You are good. So I'm going to log into GitHub. It allows me to do that. Oops. Huh. I forgot. I just typed too fast. There we go. All right. So this is the repository for our class website. Puts it all together. It doesn't have the data in it, but it has all the processing, right? So if I go to our glossary module, right, I have a folder called glossary. Here is the page. And if we look at the page, first thing it does is makes us log in, figures out who we are, and there is a select element here, right? That select element is that, right? But it's empty, right? It's just an opening select and a closing select. So what does it need to be selectable? HTML2 maybe? What does it need? What does it need from a DOM perspective? The prize goes to somebody at home here. Options, very good. Selects need options, like here. HTML select. The select tag has options within it, and that's what creates the choices, right? So let's follow the code here. The HTML has a select tag, and I've given them an ID called open terms. Why are they open terms? They're ones that haven't yet been selected. They're still open, right? Nobody's selected them yet, right? So if I go back to my code, in the JavaScript, when this page loads, it runs this function called getOpenTerms. See that? That's going to run when the page is fully loaded. That function is defined right above itself, right? So this is the definition of the function, and then I call it. The function uses the Ajax call in jQuery to go to a file called getOpenTerms.php, and in there is going to be the SQL statement. We'll get to that in a minute. And when that is finished running, it takes the data that it returns, and for each data element that it returns, every term that comes back, it's going to put an option tag with its value in there, and then insert that whole thing inside the select statement. The HTML content of that select tag will be filled with all the options that come back from the database wrapped by option tags. Right? You see that so far? So now we go to getOpenTerms. What's going to happen? So this is nothing more than a request, the Ajax request, and then the done. What happens when you come back? The PHP is what happens in the meantime, right? So we go to the PHP file, and it says, first thing you do, load this file so I can connect to the database. This has my password to the database, right? Then we learned this last week. We did this exact code last week. We used this MySQL library. We created a query, which is just passing in a string of a select statement. And then we iterate through that query and take all of the terms that come back and pack them into a variable and put them in this thing called JSON, JavaScript object notation. That's just a way to package them and send them over the network so that when they get back to JavaScript, they're in an object so we can iterate through them using this each function and break them apart and use the data, right? And what we want is the term. What's coming back really is the term. Literally, term is the column name from the definitions table. You can. You can do this all with PHP. But it wouldn't be dynamic. You'd have to reload the page, right? So when you submit, you'd have to reload the page, and your page wouldn't load until it did all those selections. This is asynchronous. So the page loads all its elements, then it goes out to the database, finds out what the options are for the terms, and inserts them in. It's a little bit cleaner. It's a little bit more programming, but it's a little bit cleaner way of doing things. Because JavaScript is better at manipulating the page settings than PHP. You have less flexibility. If you want to make a change, you got to change the whole page. It's all bound into one file. This gives you a true client server, and to the user, it's not like the whole page has to load when you submit it. Well, the whole page has to reload at any point in time. The data is sort of more dynamic. Does that answer your question? You could do this fully in PHP. It is a little bit complicated. We're learning sort of the handoff between PHP and JavaScript, and we're doing it through this thing called JSON, which PHP can create and consume, and it's almost native to JavaScript. You don't really have to do anything to it. When we get it back, so what do? It comes back as JSON. This is a statement in jQuery, parse JSON, and it literally takes that string and turns it into an object. So now we have open terms, which is an object. It's like an array. It's a set of terms. And we can iterate through each of them. This dot each function allows us, for each time there's a new term, do this. And this is jQuery. Could be another whole semester. So my intent is not that everyone becomes a jQuery expert, but learn some of the techniques or functions within jQuery that are useful for this class. So these are very useful. The Ajax function, the parse JSON function, and the each function. We'll use those again and again because data comes to us in series typically, and those are very good ways of using series. And then this whole thing doesn't run until what? So you actually click on that submit. So if you go back to the page, when you click on this, then it's going to do the opposite, right? So that first part of it, this first part here, ran when the page loaded. And that gave you guys the opportunity to choose a term. And it's coming directly from the database. As soon as Paul selects one, or as soon as he submits it, it's locked. It's no longer going to show up. Why is that? How does that happen? Well, that's pretty easy, as you can imagine. Let's go over here and look at Get Open Terms, and let's look at the SQL. Select the term from the term table, and then I join it to the definition table. This is a little bit more complex, but at the end of the day, the operative piece is here. Only give me terms that haven't been yet defined.
Right, so once it's defined, then it's no longer going to be a null item.
This is a perfect example of the cases where you want to do an outer join. Do you see how this is an outer join? So in an inner join, like the albums, if an album doesn't have tracks, I don't want to show it to you. If an artist doesn't have albums, it doesn't make sense on that list. That's an inner join. Give me a list of the albums and join it to the artist so I can see what artist is. But if there's an artist that doesn't have an album, don't show that to me because I'm really asking about albums, right? In this case, I do want you to give me terms that are not defined. So the way this database is designed, there's a term table and a definition table. And this SQL statement says, give me records that are only in the term table of which there's no corresponding foreign key relationship in the definition table. As soon as somebody submits a definition for that term, it's going to disappear from this query and it won't show up in that select box anymore. Does that make sense?
So what does it append to the definition in the database?
It puts a row, well, don't believe me, let's look at the code. So what do we do when we insert something? It's going to run this wiki new term PHP, right? And it's going to pass it what the term is, the value that's in, what is this? This is the name of the property of the data that I'm going to pass it, and this is where it's coming from, and where it's coming from is the value that you selected in that selection, in that select element on the page. What option did you choose? Get the value of that, and that's going to be our term that we're defining. This is the value that you typed into the text box, the definition, right? And this is going to be your name. Well, not your name, but your user, which is basically your email. I know what your email is when you're on our site. It's on the page as a variable. I use that all the time. Remember, our site is identity known, right? Which makes it very powerful. When you submit something, I know who it is. So I grab your name. I know who is defining this term, right? And then I send that data to newterm.php. So let's go over there and take a look at that. I have to go to that folder. It's in Wiki. And this basically insert into definition these column names, these values. And it takes, remember I just posted that data, there it's being used. Remember we saw this when we did the email contact form, $_post. It gets the data that's coming into the page. You give it, remember I had three variables I passed it, term, definition, and your email. There they are. Insert those into the definition table. And once you do that, there's a definition in the definition table that other SQL select will no longer select that term because the outer join will make sure that that's no longer null. It now has a definition. So there's a fair amount of code in here, not a lot. It's not all that, it's pretty simple, but the concepts are what's important, what should be somewhat followable to you. And the fact that there's a distinct client-server model here. What do I mean by that? We have two programs written in two different programming languages, coordinating with each other to do what we're asking it to do. We have PHP, which is very good at working with a database and working on a server, but we're using JavaScript to grab that data, and it's better at doing really nice things of getting it into a DOM. So to answer your question, Carlene, yeah, you could do this fully in PHP, but it would take a lot more code, because JavaScript is just really good at taking that data and putting it on the page, or allowing you to put it on the page. So to take this class, a couple of fundamental things pop up. It's kind of crazy that I have all these tables in my database. Why don't I just create one table? And yeah, that would be easy, but it wouldn't be professional. You couldn't do some of these things we're talking about, right? Another thing is, I could do all this in PHP. Why do I have to learn all this handoff and build all this stuff to do it? Well, I think it'll give you a more professional functionality to your site, number one. Number two is, you're probably going to write a lot less code because you're using code more appropriately, right? But these techniques are, it's a little bit to understand. It's another couple of layers. But that's, professional, when you learn about professional, capability, you have to sort of, it's typically, you don't, you could build a house in one day, but if you do it professionally, you know, you put the electricity in first, and you make sure that's working, and then you build the walls, right? So that's kind of what we're talking about here. We could make a shack, but we're trying to build a building that will last and be maintainable. And I'm not saying that Ajax is the only game type that's necessary for every case in point, but if you play with our website, just as simple as adding terms, and you compare that to, let's say, tape, you know, which is more of a pure PHP model. It's actually a little earlier than PHP, I think. Then you kind of get the sense of what the difference is to the user. You know, you get more immediate response. You get, you know, and there's still a lot. Like I said, there's things I'd like to program. You know, deletes and things like that. But it gives you a lot more control over your web page, especially when you use JavaScript, because PHP only gives you so much control without having to refresh the page. Because why is that? Because PHP runs on the server. It can't do anything unless the page gets refreshed. You know what I mean? So let's say, in our example, so let's take, this is why you want to do this. If you build the following page, I want a form that allows me to enter a new album into iTunes for sale, let's say, or a playlist into iTunes. So the first thing you do is select a genre. And the next thing you do is select the artist. And the next thing you do is select the album, and then you enter the tracks. If you have to enter submit on each one of those, that's like 4 pages. You know, if you do this in Ajax, you can literally do it on the same page and just have that page react to each step of the process. And that, number one, is a clear interface, but number two, it enhances your website. People don't stay for many pages, you know. If you have a 4-page form to fill out, they'll never stay, you know. If you make it look like it's less, by when you finish with this form, you know, hide that and do this. Or if you save behind the scenes after every couple of fields, you know what I mean, so that they don't lose it. There are all these features that Ajax brings you that you just can't do in PHP.
Is that, can we access that, or is it something that, you know?
Yeah, so it's on GitHub.
I don't know where.
I haven't put a link on our website, so this is our, like I said, this is our class. This is my repository of our class system. You could see it. It's public. You could find it. Yeah, so I think if you put in this, it might show up the repository name. But you know, GitHub search isn't perfect, so I will put a link out there. But the point is, yeah, I'll put a link out there if you can't find it. But the point is, it is a lot. Not only is it a lot of systems, like our class depends on it, and all my classes depend on it. So I am more than glad if you view it publicly. It's available. I am more than happy to have you fork it, and I'm more even happy if you want to work on it and feed features back into it. I'd be more than happy to do that. But you probably should talk to me first, so we do it in some kind of organized fashion, right? So.
What is the difference between your web programming SRJD Spring 2013 versus your SRJD Spring?
Well, this is the code that does our page. All that other one, where are we? So these repositories are nothing more, this one is nothing more than a sample repository I created for you to use, right? And you should have cloned that, forked it or cloned it. I updated it, and you can get those updates or not. You know, I just updated it so you could find some of the work that we did. But this is very different. This repository is all the code for our class page. And like I said, I'm cool about open sourcing it. If you want to see it, you can even fork it and play around with it. It's not going to do much. It doesn't have the database part of it. You know what I mean? It does have. So let me explain that. If you go, there is a database folder. There's this thing called Xanthopy. Does anyone know who Xanthopy is? So in Xanthopy is a bunch of files, and is the database file, and this is the model. This is the entity relationship diagrams. So from that, you could recreate the database. You could open this in MySQL Workbench and forward engineer that database, and you'll have all the tables. Now, there's some seed data that you need to enter right into the database, like class and section number and all that, because I didn't build forms for that. I just did that once at the beginning of the section. But from there, lessons and all that are fully, here I'll show you what the lesson builder looks like. It's called Lesson Maker. And I think I showed you this before, but it's essentially, but it doesn't look great on the screen, but it's essentially a form for creating all of our lessons. So it's both classes. It can navigate from class to class and from lesson to lesson. And this is basically where I add the content for our classes. So this is kind of the heart of the back end of the system. And all that is there. But some of this stuff, like these classes and all that, I kind of entered right in the database. I wrote it. Yeah, I wrote the whole thing. So this class started, I decided to do this 2 weeks before the class started. So think about it. This is my 10th semester, I think. Every semester I have to write a new class website, right? So, well, you have to, just because the dates change and everything changes, you know. So, and because things change, you know. I wanted to make it more mobile compatible. And then I realized that I enter the same data a lot every time. So is there a way I could use a database to make this simpler? This is the first time I've created a database-driven web content management system just for a class. So it's a pretty sophisticated, as you know, there's a lot to it. And I literally built it, you know, as we went. I got the idea like 2 weeks before the class started. I went into coding mode. By the time the class started, pretty much the lessons were there. This little glossary feature, I literally did, you know, last night. Well, I shouldn't say that. I spent a day or two on it. Yeah, so whatever. I spent, well, I had, even after I put it out, I realized I had to fix a couple of things. But you know, it's not that complex. And once this thing that I just talked about, that I just showed you, the round trip, knowing where the data is in your database, when it's applicable, bringing it in to allow your user to make choices. You don't want them to select what is the, you know, key, right? Yeah, so we're going to go through that. The rest of this class is going to focus on all of those techniques. We're going to get deeper into the JSON piece. I'm doing a code walkthrough now. Next week we're going to do it, and we'll have, you know, so the week after. So a lot of the class is that part, and you'll learn the same techniques from the newsletter subscription system we used last. Also, you know, last time we taught this also. Question?
What you decided there, and that would be something that could be similar to if you're given a site for time, they want to update their own information.
Yeah, so this is similar to a content management system. So I could give this to another instructor, and they don't have to know the code. They could create a class out of it, theoretically.
For learning positions, are there sources you can recommend where you can actually look at? Online,
well, you can take this class. It's a good place to start. No, I'm not sure what your question is.
I mean, are there applications out there on the internet, you know, in the world that you can?
There's many, many. I mean, so one of the beautiful things about GitHub is you could literally search. Like I wrote something and I shared it up there. There's thousands and thousands of PHP, JSON, Ajax applications. Well, like I said from the class, what we're learning here is the sweet spot of what's being developed now. Right? So examples are not going to be, you know, not going to be hard to find. Well, this is an example of a content management system. But there's many examples. You know, the best way to do it, and we'll do a couple of weeks of this in this class, we'll take apart WordPress and see how that works. Because I don't know what it is, probably 65 to 80% of the deployed content management systems out there are on WordPress. Just because it's free and easy and it's one button on every website. And there are pros and cons to using WordPress. But it is a more thoroughly thought through content management system than what I built. But mine is better for my needs. You know, without having to know a lot, I was able to build something that works better for me. I taught on WordPress before, and it doesn't know what a lesson is. You know, it doesn't know what. So, and you need exactly. You know, to build a WordPress site is a lot about finding modules and plugins that create the features that you want. So, would you comment it so we can follow after the lecture? Time for what I commented. So, comment, time for a break. So, do we want to take a break or do we want to take spring break? Do you guys want to, we could take it's 9 minutes, it's like we could take 10 minutes and come back for 40 minutes, which I'm more than happy to do, or we could sort of take a minute, see if there's any questions and wrap it up. Because beyond this, let me put it this way in context. You've learned the SQL that I'm going to teach you in this class at this level. We're going to do more SQL in the context of PHP code, right, when we actually apply it, but you've pretty much, you've pretty much learned everything that you need to know for SQL in this class. The next step is kind of tying it together so it makes sense, right? We started doing this in the last class. We built a PHP page that used SQL to get data on there. Now we're going to take it to another level and build some forms so we can interact with the data.
If we don't take a break, how much longer is class?
That's up to you. I mean, yeah, if we take a break, we might as well go to 10. So I don't know if there's any questions at home or if there's specific things. Bookmarker. Well, I could bookmarker. So I could bookmark it, but I guess if we're stopping, I guess is. I'm not sure how to bookmark it. I've got to learn how to bookmark because everyone always wants it. So we go back. So the other thing is, like I said, all of this, not the code we're talking about, but some of the examples that I'm showing you are in this GitHub example. So I think Paul wants to go back into the glossary piece.
Oh, I just wanted to see a lot of that stuff you were showing us a minute ago.
Yeah. So if you look, so the operative thing is this. Let me walk through this. Nobody answered, so I thought they. But yeah, if you want to do that, you want to do it? Okay, so let's take a break. Is somebody voting at home? No? Oh, to comment the code. Yeah, so,
oh, yeah, okay.
To comment this code.
And then they're asking you to comment the code that you're showing us.
Yeah,
In the JavaScript.
yeah, I'm not gonna do this code. We're gonna build examples like this. I'm just trying. This is not a class code. I'm just showing you this as an example, right? And we step through it as an example. I could go back and comment it. I think it'll be much more valuable if we actually write this code and comment that as we go along. Because there's aspects of this application that are beyond what you know about, right? You don't know a lot about this application. You don't know about the data behind it. You know, this isn't a good tutorial because it's too big. You see what I'm saying? I'm just using some code examples to show how some of these things work. So, there's one guy that wants to go till 10, but I don't think there's too many others.
Everybody else, okay. I'll go to 10.
Yeah, I think.
If you get up and you're able to walk around for 10 minutes, then you can sit back down.
All right, we're going to take a break and we'll be back. Sorry. They want me to earn my pay. So I am going to pause the recording, and we will be back at 9:10. And we might lose some of our home audience as Tony is heading down the San Padre Island, I think. But other than that,
I'm already working on my final project.
great, Chicago, great, bon voyage. So I'm going to starting the recording. And everyone wanted to keep going, but you know what? I have nothing more to say. So everybody wanted to keep going, but I'm not prepared to keep going. So we can wing it, and we can start working on some cool stuff. In which case, I might do one of these things where everyone hates, where I start jumping around and grabbing code and all that. So I could do that. But I could go. So let's do this. Let's play a game for the people who are still here, and we'll open it up for the people who are still at home. I know. Sounds like Tony is even still here. So so let's do this. We can have like a Jeopardy. You know, so I don't know what exactly. I have to think of questions that aren't on the test, obviously. But let's see. Oh, let's do this. Let's do this. Let's go to the glossary. So Flash. So what's the definition of Flash? That's not X-rated. That doesn't get you arrested. So so everyone knows what Flash is, right? Does anyone use Flash? Flash is not a codec. Flash does have its own codec built in called FLV. A codec. So what is a codec? Well, I think somebody did define that, so we could. The good news is we can look it up. I know, it'll be on the wiki, so here it is. I thought I saw a codec question. Yeah, maybe it hasn't been. Oh, yeah, media codec. So a codec is an algorithm or a means of encoding something. If you think about it, on the web, any content is encoded in some way, right? Even strings are encoded. What are they encoded in? What is a string encoded in on a computer?
AMC.
It used to be either AMC or something like that. Now it used to be ASCII. Now it's typically Unicode, right? Unicode, which is how does the byte look for every letter, right? And any kind of media, whether it's text or audio, has to be encoded for it to be digitalized, right? There has to be some kind of means to make sense of it. So MP3 is a codec. It's typically a pretty universally free codec, but it's a codec that encodes audio and at the same time compresses it. So another codec that's similar that has compression algorithms is not for audio but for images. JPEG, right? It's a codec. It's a coding mechanism that allows you to take something physical, turn it into something digital, right? So with video and other media, we have new codecs that are designed to be more efficient and therefore show media on the web in a more open manner. But Flash is essentially, Paul wasn't that far off, it is sort of like a codec in the sense that it allows you to author a bunch of pixels and then it encodes them in some way. And there's only one program that knows how to decode it, and that is the Flash player. So rather than Adobe licensing the codec to the browsers and allowing them to just play Flash in the browser, they made it proprietary and they said, we're the only people that can own the codec. You have to download the Flash player from us. And that made it separate from the browser, which, for the last 20 years hasn't been that bad of a thing. But now that we have mobile devices and lighter, simpler hardware, the Flash component is just another layer that's no longer necessary. The codecs that do just as good a job of being built right into the browsers. So that's the good news. The bad news is the people who are taking the HTML5 class now, there are different codecs, and no one browser supports them all. So it gets a little tricky. So, but Flash, if you think about it in the big picture, I don't know what just happened there, is essentially a codec for video. You can encode video using its FLV, which is a video format. It is a codec. And it was, like I said, it was very popular. In fact, YouTube was built on it. But now Flash is seen as sort of pre-HTML5 technology, because HTML5 has made the browsers capable of doing that. It's not perfect yet. If you think about it, there are two types of browsers, right? There's
Everything in Internet Explorer.
Yeah, exactly. You're close. There's browsers that are made by people who do it because the world is better when there's great browsers, like Firefox. And then there's browsers that are made by corporate entities, like Microsoft and Chrome. Chrome is a corporate entity, so they're not a nonprofit. So some of these codecs, like MP3, are not open source. And the free browsers have a hard time paying licensing for a codec when they're not making any money on the browser. So Firefox and Opera, the two primary open source browsers, have traditionally used codecs that were also open source, just so that they don't lose money in what they do. Whereas Google Chrome, Microsoft, and the third owned browser, which is Safari, have typically supported the licensed codecs, which up until now have been faster and more proficient, but they've costed money. So Adobe Flash preceded all this. It was a proprietary codec. Now browsers have the ability to embed video and audio codecs like they've always done with images, but it's still emerging what the winner codec will be. And therefore, to do HTML5 video, it's very easy to do within a tag, but you have to code your video a couple of different ways and provide fallback mechanisms so that different browsers can transparently play it. Right?
So,
none of that's going to be out of the midterm.
So Flash is really it's really a wrapper around the codec, right?
Yeah, Flash is a wrapper around the codec, right? It's even more than that, it's a platform. You literally write the content that becomes the codec, that becomes encoded. So unlike most video codecs, which just do the encoding and the decoding, Flash allows you to author. You can actually put pixels on a movie and then code that, because it has the Flash authoring environment, which is really where they made their money. They never charged for the player. And it was very useful because it was the only way to do animation on websites up until like the last couple of years. And it was up until like 4 years ago, it was the only way to get anything other than 5 fonts on your web page. Because people would literally use Flash just to put typography on a website, which if you think about it is kind of crazy. And there were many different techniques, Kufon and all these others, that are unique ways of putting content into Flash so it renders strongly, custom fonts into a website. But it was also used for video and animation and other things.
And what I think it is also is, since we're doing it or seeing it in YouTube, when you say video, you mean video with audio.
Video with audio, right? Yeah, and then Flash does more. So we're getting some comments from home. So yeah, there's a Flash streaming player, so you could stream audio or video, and you could tie Flash to a camera, so you could get a video streaming. There's a lot of capabilities in Flash, and for computer automation and maybe some game design, Flash is still a pretty interesting tool for the things that it was mostly used for: putting animation on a web page, putting better typography on a web page, or putting video on a web page, it's now viewed as not the current proper way to do it. With video, it's a little stickier. We're still using it for video in some cases, but mainly as a fallback. Writing to Canvas. So
Is a class that does it talk with HTML5 and JavaScript?
right. So the question was, so if you don't use Flash for making games, what are the alternatives? And the real alternative to Flash, whether it's games or anything, is what quote-unquote HTML5. And in HTML5, there's a new tag called Canvas. And that is essentially like the Flash stage. If anyone's ever used Flash, it has the concept of a stage, which is a rectangular piece of real estate on which you can animate. And that's exactly what Canvas is. Right? And we use Canvas in this class. Did we do that wavy thing in this class?
Yes.
Yeah, so that's an example of Canvas. People used to use Flash for that all the time. You know, that wavy footer that we did. That was a very common use of Flash. Little headers and footers that do little cute things. So, but none of that has anything to do with our class. Let's look at some other. Let's see, what is pertaining to our class here? So, JSON. Talked about that tonight, right? Is there any questions on the midterm? Well, there might be. I don't know. But JSON, is it a language? Is it a... Who wants to try to define that? Let me try. It's kind of a codec. Yeah, so it's a way... so here's what it is. It's a way of sharing data between different worlds, right? PHP is running on the server. JavaScript is a different programming language running in a browser. And we just do that little code example I showed you on GitHub, but even last week we showed you how we could use JSON to get the data from one to the other. And the way it does that is use the lowest common denominator of data, which is it turns it into a string. But it turns it into kind of a structured string, really a fancy comma delimited string, so that PHP can stringify. It has information that are in objects, that are in these variables. Using JSON, you can literally take all those variables and put them into a string and pack them, yet make that string smart enough to remember what the name value pairs of the variables are. And then when JavaScript gets it does what's known as parsing. It takes that string and breaks it up, and it finds all the commas, and it makes sense out of it, and it turns it back into an object that it can then iterate through or work with. So JSON is like a lowest common denominator. It takes something which is in a variable, a complex variable, it turns it into a string, it allows one program to send it to another. When that second program gets it, it can parse that string and turn it back into the variables that it was originally designed to look like. And in that way, it is, you're right, Paul, it's kind of a very simple encoding mechanism. It turns everything into a string with a way of unencoding it so it makes sense on the other side. And it was invented by this guy named Doug Crockford, who is a sort of a famous, he's our hero from the JavaScript class, but he's sort of our, here I think it's this site that we want. He's sort of a hero of JavaScript, and what he calls it is a subset of the JavaScript language. It's a way of turning a string into what's in JavaScript is called an object literal. For the purposes of this class, all you need to know about JSON is that it is the sort of glue between, it's the glue that we'll use to get data back and forth between JavaScript and PHP. Or, in other words, between the client, which is the browser, and the server, which is the web server. And it's the means by which the data can go back and forth. It's very hard, if you think about it. Before JSON, programming languages couldn't really share data. They had different representations for that data. They could do so in very simple ways. You could get a comma delimited file out of the Excel and load that into Access or something like that, or maybe even load that into a SQL database. But it was limited and it took labor. You had to do it. JSON allows a programmer to do that type of thing really easily, right? So that's what JSON is, and it was invented by one of the guys that leads development on JavaScript, and that's more than you'll have to know. In fact, I don't even know if there's a question there on that. Let's take another. So you guys pick a term.
How many questions are there?
25.
Oh.
PHP, we talked about that.
Search engine optimization.
Search, well, there's a misspelling, so I get 2 points off of that. So what is SEO? What is search engine optimization? It's a good topic to kill 20 minutes. So it's I guess the most broadest term is it's optimizing your visibility on a website's or a web page's visibility on search engines. Right? So search engines are computer programs that are an algorithm, and Google created it's actually broken up into a bunch of different programs, and you can think of it really as three. And it really is a good idea, if you build websites, to go to Google. There's 1 or 2 fantastic tutorials that go through how they index the web. But if you think about it, that's what their purpose in the economy is, to make sense of all the pages that are out on the web in some meaningful way that people can use it as a tool to find what they're looking for. And they do it in a way that, you can argue back and forth and the government could sue them and all that, but they do a pretty elegant job of walking the line of providing a very valuable service while making a ton of money advertising. Just like David Sarnoff did with television. It wasn't about Leave It to Beaver, it was about the soap, right? It wasn't about Judy Cleaver or any of that. That was just a way of getting those soap commercials on there. Google's a little different. They really do these things as of value, but yeah, they do make a ton of money on it as well. So, search engine optimization, Google has, in essence, 3 programs. One crawls your website and all websites and tries to make sense of what it is about. Right? So there's the crawler. Then there's the indexer. Right? It takes what the crawler comes back with and tries to organize it in some context. So that website's about that, and this website's about that. What makes them different? What makes them unique? Why would I show a searcher one versus the other? So it sort of looks at the big picture and tries to make sense of what every domain and every page is about, and catalog them into one giant database. And then there's the ranking algorithm. That's the program that within microseconds of you typing a letter, it figures out what's the best web page out of the 20 trillion web pages there are to show you. Pretty easy, huh? So each of those is a separate program that does separate things, and website optimization or search engine optimization is understanding how each of those works and understanding how to make your website appear to Google and appear to users as specifically as possible about what it is. Right? Some of that is the content you put on, but some of that is the HTML and the organization. How you put things is important. So Google looks at hundreds of different things in every web page. The first thing it looks at is what? The title. It assumes, I think we have a link coming, type ahead. Type ahead is a cool feature that is, so autocomplete. So this isn't really directly related to Google, and I'll talk about Google's autocomplete in a second, but this is a JavaScript implementation that allows you to put autocomplete on a website. You have to create a taxonomy, or go to a taxonomy to find it, because you have to know what to autocomplete. But what was I saying? So the first thing that Google looks at is the title, because it assumes that the title of a page, which is 50 characters or so, is the best haiku about what that page is about. And you, as a web designer, have to take advantage of that. You want to create the best possible 50-character haiku to explain what this page is about. And it's got to be unique from all the other trillions of pages on the web. Because when somebody types in something, you want that page to pop up. Right? So this happens all the time. Now let's look at this. This is a Santa Rosa I think we saw this last week. Landscape garden. Now if we look that up on Google, that's page 1, so that's 10 entries. And we've got a bunch of, Google goes out on the internet and finds all the pages that have anything to do with that term. We lost our SEO, but as of last week, one of our examples was on here. Let's see if we can find it. And that was simply because of the title tag. But they probably realized it was not really a business. Or the person that posted it might have taken it down. But yeah, I don't see it here anymore. But just because we put a page up about that was our example, that wavy footer thing, it was showing up on Google because, and this happens all the time. If you, like our site ranks pretty well. If you do PHP, MySQL, tutorial, Santa Rosa. So here, this is our site right here. This is the site from the last class I took. I taught, right? Spring 2012. So out of all the pages in the world, so that has Santa Rosa in it. That's in the domain, so that's pretty easy. But let's look at this title. Let's try to find something on this page that's really unique. Let's do this. Let's do a search on that and see what we pop up. A lot of competition if you think about it. Yep, I'm on page 1. So let's do this. Let's look at the title of that page. Right? Well, we'll get found for that because that's pretty unique. Right? Well, it has Santa Rosa JC, so it's going to pop up. Yeah, let's try this. That's pretty general. That's pretty general. Yeah, that's pretty general. Yeah, this is pretty. It's pretty unique. Stack Overflow, PHP. We got to be. Oh, here we go. So we're number 5 for that term, which is a pretty, a simple PHP page with stage to. So it's it's word for word what I typed. We didn't get number 1 because Google knows that Stack Overflow has thousands of articles that pertain to PHP and MySQL. They also know that when it presents those articles, people click on them. So they're smart enough to know who, they show these pages all day, and they see what people click on, and they make those rank higher too. So there's all sorts of things that go into search engine optimization, but there's basically 3 ingredients. Relevancy, how relevant is the information on your page to the term that was typed in. Authority, how authoritative is your website? SantaRosa.edu is pretty authoritative. It's a college website. It's not a fly-by-night thing. It's not a business. It's a government. It's a pseudo-government entity, in fact. So and Stack Overflow, like I said, it has a lot of authority. Yeah, there's something called Google PageRank, and it's not a database in the sense that it's no longer published. But they used to publish it, and it's on a scale of 1 through 10. A website that goes up on day 1 would have a page rank of 1, with very little authority. But as you gain authority, you go up, and it's a logarithmic scale, so there are only a few sites with 10, like Google. But those are sites, authority comes, one, when people are attracted to it and click on it when they present it, but more importantly, when other sites link to your site. That shows that people respect it. If you think about it, Google was created to search scientific information, to do research. So if a paper was cited by other papers, it had authority. And Google PageRank is what made those guys billionaires. It was the patentable feature of their search engine that differentiated Google from other search engines. Right? If you think about 20 years ago, everybody in the Soviet Union was dropping out of college to write search engines. There was a big opportunity to do so, and Google grabbed it, and they were able to do two things: capitalize on the advertising that the search engine was able to attract, but two, they patented this PageRank concept, which is the authority of a site is equal to the sum of all the authority of all the sites that link to it. And it's named after Larry Page. That's why it's called PageRank. It's not about web page. So, I think it's patented or whatever. It's protected by them. Other people can use that concept now, but it's sort of like one-click checkout at Amazon. They own it. And they used to publish it. They used to be able to see what Google PageRank had signed, and every year they used to go through and update their PageRanks. But now it's behind the scenes in their algorithm, and it's probably more complex than just a simple number from 1 through 10. But it used to be their way of trying to quantify authority, because one of the things they measure is authority. Now they measure it in many other ways, including PageRank or something equating to that. Sure, SEO is a competitive. So the word optimization is very important. If you're number one, you could fire your SEO guy, right? Because you're number one, right? So it's when are you optimized? When your phone is ringing enough that you're happy and you're making money, right? Why do you optimize the site? To get more people. It's like buying a new restaurant closer to downtown, right? Updating your website to put on all the features you need to better compete with all the other people that have websites is like buying a more centralized location in the mall, and that is an advantage. You get more foot traffic. Search engine is like the 21st century equivalent of foot traffic. Right?
So they pay attention to things like Facebook and things like that, or progress things, everyone was.
Yeah, so they pay attention to things beyond just what's on the page now. Things like social media signals. All these things they pay attention to, they call signals. And thousands of signals are assessed every time you literally type in a search, right? Just like I just did. So it goes through all these signals, and some of the signals are off-site. Like, do they even have a Facebook page? These days, it's kind of like if you don't have a Facebook page, they don't even trust you that you're a business anymore. So, and is it active? And are people linking from Facebook to your site? And things like that. So there's thousands of signals that they go through. And like I said, Google writes some pretty good papers. Their goal is to make you good at search engine optimization. They want your site to do a good job and reflect what it's about. So, none of this is magic, but it is a bunch of techniques that are specialized, and there's not a lot of education in it, but it's starting to emerge. So the JC has a course plan in these techniques. It hasn't started yet. It might start in the fall or the spring of next year. And there are other universities that are starting either classes or whole programs for search engine optimization. And even search engine optimization, as Lisa says, is sort of a subset of internet marketing as a whole, which includes social media and other ways of increasing your presence online, blogging and all of that stuff. But currency is another signal of relevancy and authority. If a website hasn't been updated in a year, its authority is not going to be very strong, right? So all of these, the time it takes for the page to fully load is one of their biggest signals now. Page load speed is very important to Google. If they're going to rank you number one, make you the number one site for something, They don't want to send their users there. It takes 15 seconds for your page to load. You know what I mean? They have a vested interest in presenting good sites. But something as simple as a slow page load time, like fat images or an audio file on your homepage, can mess you up, even if you have perfect SEO. You know, there are all sorts of things. Good signals, you know, doing everything right is good. Doing one bad thing is really, really bad. You know what I mean? It's kind of like driving a car. You could go for 30 years and everything's fine. You have one. Google is kind of like that. You know, they'll take all these good signals and that's good. But if you do one thing wrong, it can really tank you, like your page load or something like that. Currency. So if you haven't updated your website, if you have a blog on your website, Google knows it. You know, they could think about it. They spend all their life. This robot. What does he know? He knows HTML better than all of us. He navigates the code of the web pages and tries to make sense of it. So, you know, organizing your page in the right way. HTML5, dividing it into sectional components. You know, creating a hierarchy of your content. Your H1 should always be at the top of the page and cover the entire page topic. And then you can have subtopics in H2s or H3s. All of this is very important. This is what Google sees. You know, you could design the style of your H1 to be half the size of your H2. They don't really see that. You know, they do look at that, but it's not a big thing. But what they do is say, that H1, it's an H1. It's the most important, you know, other than the title, it's the most important thing on the page. There should only be one H1 on a page, right? In a well-designed page. Right? So, you know, search engine optimization is not a topic in this class, and unfortunately it's not a class this semester, and I have a little bit of experience in it, so I always throw in a half hour and a half time in the classes just to go through it, because I think it is, it's not another profession. It is part of web development. You know, today in the real market, it's another profession. Does that make sense? People build websites and then they hire an SEO guy. And a lot of times in private practice, when I get hired, it's to do SEO, and it really turns into building a new site because that's the best, you know, sometimes that's what it takes. But the point is, the customer wouldn't be served if they hired an SEO guy to try to do what he could with that without being able to build a new site if he needed it. Does that make sense? And that's why I say it's one thing. Today you can get by being a web designer and saying, I know a good SEO guy, but I guarantee you that's not going to be the case. It's part of the same thing. You can't design a site and then SEO it. It just doesn't work that way.
That has to be part of the development process.
A web designer, when he puts a page together, already puts it together for the user. How is it going to look? That same brain has to put it together for the search engine robot. You know what I mean? Does that make sense? Because it's the same content, it's the same structure. It's not a different skill. Yeah, there's one that just came out, and that's everything. I always just Google. It's a thing. Google. Type in Google search engine in the Google search engine. Yes. Let's try guide. Yeah, Webmaster Guidelines is probably a good place to start. And it all starts with a guy, this guy right here, Matt Cutts. So this guy is, he's in charge of search engine quality at Google. He's the guy that makes sure that the search engine provides good, meaningful results and doesn't provide spam. And he's the guy typically that writes, you want to read his blog, and this might be his personal blog, but he's the guy that typically writes these, how does the search engine work? And he's a pretty smart guy if you ever see videos of him or hear him speak. But somewhere recently I heard that he wrote a guide. So rather than me stumble around, in front of everybody, I will look at it and find a link and post it to you. And like I said, this is peripheral to the class, but my personal feeling is it's always a good thing to bring up in a web design class because it's part of web design. So, and look, he's friends with Larry Page, so it's got to be, works for him. So, but somewhere recently he posted a whole website on how Google works, and I think that if you're interested in that, it'd be a good place to go. So that was all about SEO, that one term. Is there any, I don't know how we got to Firefox. Is there any other, let's try one more and then we'll call it a break, right? This is a good one. Does anyone know what the document object model is? The DOM, D-O-M. You guys know that. Right. Does that make sense? So, remember we talked about encoding, right? Think about it. Let's take a simple example like an image. What does Photoshop do? It takes some kind of encoding representation of an image, pixel by pixel, and puts it into memory, your computer memory, and then puts it on renders that from memory onto the screen, right? So in the memory of the computer, the RAM of the computer, every pixel has a representation. What's its color, what's its opacity, whatever, right? And when you change a pixel, using Photoshop, you use a spray paint tool or whatever, it goes into memory and changes the attributes of the memory, the variable in memory that represents that pixel. And then when you save that, it stores it on the hard drive. It takes that whole encoded thing and stores it on the hard drive. Well, think about it. A web page is nothing more. What do we do when we write a web page? We're encoding. We're using tags to encode a document. This is the head of the document. This is the body of the document. This is a headline in the document. This is a paragraph. So we're encoding it. What the DOM is the memory representation that the browser uses. It takes all of that encoding that we wrote. It's a string that comes in from the web server, and it puts it into memory in a hierarchical model. This paragraph belongs to this div, that belongs to this section, belongs to this document, right? It goes all the way up to the document, and that document object model is the hierarchy of everything on the page. So in JavaScript, what you get to do is treat the DOM like they're variables. And all you need to do is literally update a variable that represents a DOM element, and the thing on the page changes. Right? That's how JavaScript works. So the DOM is the memory representation of all the elements on the page. Right? Not at the time it loaded, but at the current time, because it could have changed. It could have changed because of CSS, which will change its properties, but it also could have changed by other JavaScript programs. It's a live memory model. So the DOM is very important. It's something that you could get through HTML and CSS and build web pages without knowing that you're actually using a DOM. You see everything as tags. But that's not how the browser sees them. It sees them as elements with properties. And your ability to manage and change and update those properties and elements is what makes JavaScript, gives JavaScript the ability to create dynamicism on the page. You can do anything to a page. You can make it flip upside down or whatever. With one statement, just rotate. Right? Rotate the page, or rotate a paragraph, or whatever. So we know that there's a rotate in CSS, right? It's a property of the DOM. All we got to do is get JavaScript to tweak that one little variable, and everything goes from top to bottom. Right? We do that in the JavaScript class. So the DOM is important, not necessarily a big part of this class, but something every web person should know. So, any more questions? We went through the whole class tonight. We created just, I didn't know, so that explained that. So if there are no more questions, I'm ready for spring break. I don't know about you guys. 2 hours from now, the midterm opens. So you could do that. I think it's open through Thursday. It'll say it on there, through next Thursday. So you have plenty of time to take it. Don't quote me on that, but I think it's at least like the 17th or the 18th. And the definition thing is open now. You can do that whenever. And like I said, the faster you do it, the more choice you have of the words. And did you do it on your phone? You did it on your phone?
We did it. Yeah, we did it on my phone.
Cool. All right. Any other questions? Your class dismissed. The 18th is Monday. Okay, so let me say this before we break up. The 18th is Monday, so I might have misstated. Don't wait until Thursday to take the day.
Wait. You know what? Just put it on for Wednesday, because this is safe, and now Wednesday's not safe.
You know what? I'll open until Wednesday. How's that?
Wait. Okay, wait. On the schedule, it says we have until April 1st. April 1st.
For this?
To do our final proposal for our,
Oh, right, yeah.
Then why are you making it conditional to this thing?
You know why? Because, yeah, okay, you're right. I contradicted myself. I did contradict myself.
You want to start thinking about it now, so
I do it for sure.
Happy spring break. You too.
I've been on spring break worried about this.
I'm not going to.
That's what I'm saying. Do it now.